Hello and welcome to the machine learning part of our course. I want to congratulate you on completing the introductory course on Python programming. In the next step, we will go through machine learning algorithms one at a time. We will start with one of the most basic algorithm called linear regression, which can be regarded the foundation for us to learn other advanced algorithms. These are the contents that we are going to cover in this session. We will understand the concept of correlation and then slowly connect the dots and move to simple regression. Slowly we will deep dive into more and more aspects of simple regression and try to understand how we can make our simple regression model better and better. So without wasting our time, let's get into correlation. What is correlation, or what is the need of correlation? We will try to understand this by taking 4 examples. First would be, is there any association between hours of study and the grades of a student? Or is there any association between number of temples or churches in the city and the murder or crime rate? What happens to the sweater sales with the increase of temperature? What is the strength of association with them? What happens to the ice cream sales versus the temperature? What is the strength of association between them? With these 4 examples, yes, we can definitely say there is some sort of association in each examples to different variables. But how do we get to know that which out of 4 is representing more association, or the degree of association represented by that example is better than the other one? So to do that, we need to quantify the association on a scale which we can use to find out which of these examples is showing us more or very strong association. So to do that, or to quantify our association, our answer would be we need to find something called correlation. So correlation is a measure of linear association. Mathematically, which it can be called R, is the ratio of variance together of 2 variables divided by the product of individual variances. This ratio is also known as Pearson correlation. As this is a ratio, the value of this ratio must be between 0 to 1. So let's see with the correlation coefficient values, how do we find, or what would be the degree of association by putting correlation coefficient on a scale. Let us try to put correlation coefficient on a scale and understand what kind of value represent how much degree of association. So correlation of 0 would mean that there is no linear association between 2 variables. Correlation of 0 to 0.25 would say there is negligible positive association. Correlation of 0.25 to 0.5 would mean there is a weak positive association, and correlation between 0.5 to 0.75 would mean there is a moderate positive association. But if correlation value is more than 0.75, we would say there is very strong positive association. So far, the values that we have seen or tried to understand on a scale were all positive. What if the correlation coefficient that we get is in degree of negative 0.75? To understand this, we will go back to the examples. The third example, what happens to sweater sales with the increase in temperature? Well, with the increase of temperature, the sweater sales go down. So there is a strong association, but it's a negative association. So our correlation coefficient for in this scenario would be negative. This is how we interpret the negative correlation coefficient. In the next step, we will try to understand how to calculate correlation coefficient in Python in our Spider coding environment.